All right, today's lesson or videos on implicit differentiation. Up to now, we've been using explicit differentiation, and this is what we've been used to. Let's see, getting my pen to work. Here we go. So, explicit differentiation or explicit function is where we say y is equal to 3x squared plus 4. So y is defined by x. And if we want to take a derivative with respect to x, dy dx, then it's equal to the derivative of 3x squared plus 4 with respect to x, which is equal to 6x. Follow the rules. But sometimes y is not always defined explicitly as a function of x. For example, if we have y cubed, okay, we want to take the derivative of y cubed with respect to x. This implies that y is a function of x. Now then, we don't know what that is, but that's what it implies, hence implicit. Now, to take this derivative, we've got to use the chain rule. See, in this case, this y cubed, this is the outer function. We don't know what x is. We don't know what the inner function is. So let's take the derivative of the y cubed with respect to y, 3y squared, and then the derivative of y with respect to x. So, the derivative with respect to x of y cubed is equal to 3y squared dy dx. Okay. Another form of this might be, let's put them together. Let's see. What is the derivative with respect to x of x y squared? All right. Well, first of all, we've got a product here. So we've got to put the product rule. The first thing we're going to do, this is going to be equal to the derivative of the first function times the second function plus the first function times the derivative of the second function. So just the old product rule. The first term here is very easy. The derivative with respect to x of x is just 1, so I've got 1 times y squared. Over here it's plus x. Now, see, these two things don't match, the x and this y. So I've got to apply the chain rule here. So take the derivative of y with respect to y. We get 2y. And then y with respect to x. Since we don't know what that is, we'll just write it as dy dx. Clean that up a little bit. And so the derivative with respect to x of xy squared is equal to y squared plus 2xy dy dx. All right, now that we've seen a couple of examples of this, let's take a whole equation and take the derivative. For example, we want to find the slope. So, let me get a little bit more room here. Here we go. There's my cursor. I'll scroll up just a little bit. All right, let's take this. Y cubed plus y squared minus 5y minus x squared equals negative 4. We want to take the derivative with respect to x. So we've got d over dx, this whole thing, y cubed plus y squared minus 5y minus x squared. And then we've got to do it to the other side as well. Negative 4. Now the derivative with respect to anything of a constant is equal to 0, so let's take care of that. These are different terms, so we can take the derivative with respect to x of each individual term. So d dx of y cubed plus d of dx of y squared minus d dx 5y, and I'm going to run out of room here. Let me move this over here. Okay, minus d of dx of x squared is equal to 0. All right, now using that chain rule that we used above, take the derivative of y with respect to y, which would be 3y squared. Then we got to do dy dx. We just don't know what that is. Okay. Now the next one, same idea. We got 2y dy dx. And then the last one here, or this one, we got what? Minus 5 dy dx. And these match here, so that would just be 2x is equal to 0. All right. Well, we still want to solve for dy dx here. So you can see that we got it in three terms here, not in this one though. So let's move this over by adding 2x to both sides. So that cancels out there, and 0 plus 2x is 2x. Let's group our dy dx's together. So I got dy dx is common to all three of those terms. So I've got 3y squared plus 2y minus 5 is equal to 2x. Let's move it a little closer down there so I didn't quite line it up, did I? Okay, here we go. And now to finish that off, we can say that dy dx is equal to 2x over 3y squared minus 2y minus 5. Now, see, this is what's different about implicit functions or implicit differentiation, is now that my derivative is has to involve both terms. Okay, let's try it with an ellipse and see if we can find excuse me. Let's see if we can find the slope of the tangent to this ellipse. Let's first write out the ellipse. Okay, here's the function ellipse. X squared plus 4y squared is equal to 4. And we want to find the slope at square root of 2 negative 1 over square root of 2. We can double check to make sure that those fit within our, those are indeed values. Let's see. Square root of 2 squared is 2. That would be 1/2. So 4 times 1/2 would be 2, so 2 plus 2 equals 4. So they didn't lie to us. That's certainly a point on the ellipse. So let's take the derivative with respect to x of both of these. Okay, of x squared plus d dx of 4 y squared is equal to the derivative of a constant, which is 0. Okay, we know that that is 2x. So those agree. Now this is x and y, so we're going to have to use the chain rule here. So with respect to y, that's 8y dy dx. That's equal to 0. So we can move our 2x over. And divide out the 8y. So dy dx. See, the derivative, the dy dx, that represents our slope. So there we have that, and that's equal to negative 2x over 8y. So over 8y here, clean that up a little bit. So negative x over 4y. Well, now that we know that's our slope function, we can take our point that we want to find the slope for, that square root of 2, negative 1 over square root of 2, up there. So we'll just plug that in. So our slope at this is equal to negative square root of 2 over 4 times negative 1 over square root of 2. Okay, those negatives cancel each other out, so we're going to have a positive answer, got a positive slope. Take the top, flip the denominator over, and we've got 2 over 4, which is equal to 1/2. And that's our slope. All right. Well, we're done with this today. Talk to you later.